Thank you very much. My name is Attaullah, and I'm presenting a new authentication solution for smartphones. So this is the presentation outline. I will start with formulating why user authentication is important. I will motivate and list down the problem statement. Then we will talk about what do we have at the moment, existing solutions and their limitations. Then I will introduce behavioral biometric, what exactly it is, followed by our solutions, and we will end up with some conclusions. So fine. My question to you is, who doesn't own smartphone? Anyone who doesn't own smartphone at the moment? No. So 61% of the people, they are using smart gadgets. Smart gadgets means they are using smartphones, smart watches, smart glasses, and smart watches as well for different applications. Okay? And by 2025, for example, 72% of the users will use internet from their devices, from these smart gadgets. So there is a great motivation. Why these smartphones or smart gadgets are extremely popular? Why we cannot live without them? The question is, they are extremely popular because of these features. These features means they provide us anytime, anywhere computing. They contain powerful processors, and they have long-lasting batteries, and they are used for a variety of applications, not just call making, not just call receiving. And they have easy-to-use interfaces as well. So this motivates the usage, and our study says that over the period of 24 hours, we access our phones every 6.5 minutes. So after at least 150 times a day. Now, accessing this smartphone every 6.5 minutes means we are actually using it frequently, but for smaller sessions. Now the question is, this, as a result, for example, the UK has now become a smartphone society. The use of smartphone is increased across different age groups. So, computer usage has fallen actually. And the usage of these smartphones, for example, they are not just limited for call making or call answering anymore. They are used for a lot of sensitive transactions, for a lot of sensitive computations, like social networking, like online banking, Google Wallet, for example, we are using smartphone for transactions as well. The question is, positive side is, we are smartphone reliant now. The negative side is, it keeps on, collecting our sensitive data. That data needs to be secured. Okay. So all of these apps, our study says that we all have at least 41 applications installed on our phone. So all of these apps, they are actually generating a lot of sensitive personal data that needs to be secured. Now my question to you is, how can we secure this data? Authentication. So what is authentication? Authentication is actually verifying the identity of the person. I am Attaullah. How do you identify me? How do you verify my identity? I will claim my identity. I am saying I am Attaullah. You are, by looking at this card, asking me for my secret, you are actually verifying my identity. On smartphones, or in general on computers as well, we have available schemes. We have knowledge-based systems, means you have to remember something. Pins and passwords are classical example for this, and graphical patterns as well, and characteristics based as well. So characteristic based mean fingerprints, biometric, face recognition, iris recognition. These solutions, they already exist. Okay, so they are not new. Now, behavioral biometrics here is actually the way you are interacting with your phone. The way you are entering your PIN, for example. These are behavioral biometrics. My voice could be used to identify me, to verify my identity. Motion-based sensors could be used to identify users. So all of these techniques are still, they are there. The question is, Like pins and passwords, they are non-transparent. What do I mean by non-transparent? Means you need to enter 150 times a day to actually access your phone. So you have to do something extra to get access of your phone, right? And passwords, to be honest, for me, they never provide authentication. They provide authorization. So whoever remembers, whoever finds the pin or password by just thinking, we are using smartphones in public places, so it's quite easier to find the password of a person. And another problem is, for example, there is a trade-off between security and usability. This table that you are seeing, for example, like out of 4.2 million passwords, for example, 41234, for example, is the password used. So the users use simple passwords, okay? And it's because it's hard to remember the complex passwords. And that actually creates a problem related to usability. And if your password or PIN is 1234, you are not alone. And also for graphical passwords, when we are using our smartphones, we somehow leave our smudges on the phone. Those could also be exploited. So, as a solution, as a replacement, we have physical biometrics. Physical biometrics means usage of physical body characteristics to authenticate a person, to verify the identity of a person. So, physical biometrics, they are also non-transparent. Imagine 150 times a day you have to, take a selfie to unlock your phone. They are non-transparent, that's why they are non-usable, to be honest. And they are affected by environmental conditions as well. For example, this image that you are seeing here is the smartphone made by Fujitsu. It takes 15 to 20 seconds to actually, get your irises to authenticate. So they take long. And attack vulnerability, one of the studies says that these fingerprint sensors, they could be exploited, they could be hacked, with a success rate of 80%. So they have security plus they have usability issues. So what do we have then? We have behavioral biometrics. What is this? Behavioral biometrics is actually the way of authenticating a person based on his gestures, based on something that he applies, for example, to perform a task. I'm speaking, so my voice is different from every other person, for example. So signature, voice, keystrokes, these are examples of this authentication. Behavioral biometrics. Now I'm presenting my solution, 2 in 1. What is it? This method is a bi-modal authentication system, behavioral biometrics, but bi-modal. When I say bi-modal, it's like 2-factor authentication. Okay? Bi-modal means it is going to use 2 different modalities to extract digital signatures from users. One modality is when you enter 8-digit, it could be 4, 6, 8, it's your choice, but based on the differences in the 8-digit PIN that you enter, timing differences, I would say, okay? And the way you write on the touch screen, the way, not what you are writing or not what you are actually typing. This could be used to authenticate users. How? This is our approach. So, when you enter any combination of 8-digit PIN, doesn't matter if you enter 8 zeros or 8 ones, it's perfectly fine. So we collect keystroke data, and when you write something on the screen, we collect signature data. This could be your size of the fingertip, this could be your force, this could be your acceleration, velocity, everything. We process all this data, extract relevant features, combine these 2 feature groups, and we perform classification. Mind you, this classification here, I will talk about it here. Okay, so before here, this classifier here, for example, could be trained in 1-class classification scenario, multi-class classification scenario, binary class. We will see them later. So here, for example, in methodology, the data collection we performed, for example, from 20 participants, but they were not security experts, to be honest. All of them, they were students, and we used Samsung Galaxy S21 phone for data collection. We also checked the impact of different activities. While sitting, how you write your name, or how you enter your password, for example, and in different sitting, standing, and body postures and walking body postures. The features, when you enter one, for example, 2, 3, 4, the point is the time you are taking to enter these pins or time you are taking across these pins, for example, this could be used to authenticate person. This could be, the feature for keystroke dynamics. And for a signature, for example, the features could be, the size of the fingertip you are applying on the touch screen, the way you are writing from X, Y direction, Euclidean distance between those points that you touch while writing. These are all statistical features, very easy to extract, very easy to process, and very quick for the classifier to learn. So we extracted these features and we created a final feature data. Now, before applying classifier, for example, there is no way to find out which classifier is going to work. Okay, so what we normally do, researchers, we normally take what state-of-the-art says, what other classifiers, what other papers have used, for example. But I think it's better to visualize by your own self, for example. For this data set, which classifier is going to work? This is the representation of Disney. I normally visualize this data and then check which classifier actually is able to learn well by looking at the boundary of the decision made by those classifiers. And from here, I can see that all these three classifiers that I'm going to present, for example, KNN, deep neural network, or SVM, they could be used for this authentication task. And also, parameter optimization is extremely important too. So we perform this parameter optimization for all these classifiers for different parameters. You see, for KNN, number of neighbors was important. For SVM, kernel gamma and C we computed. And so this frequency that you are, this validation accuracy that you are watching here, 94.27, this was on the training part of the validation set, okay? So this way we learned the best parameters and then we applied those parameters for final classification. So here you see these are unimodal results. Unimodal results means this is only on the keystrokes. So the data of the keystroke was used to train the classifier, and you see here, deep neural network, here I show you the structure of deep neural network as well, like it had 3 number of layers and number of units were 288, 512, 384. Actually we use Keras tuner to find these parameters because before that we cannot know which architecture is going to work. So these are the unimodal results for keystroke dynamics. Here you see DNN performed well, yielding a true accept rate of 68%. This true accept rate means how accurately the smartphone identified me as a caller. Correct classification after owner or the legitimate user. So it gave me a true accept rate of 68.1 and overall accuracy of 83.2. For signature, the same way, for example, signature, all the classifiers are mainly accurate because it's a very unique style of writing. So DNN also performed here and outperformed other classifier, achieving 97.2. Yeah, KNN performed well as well. And in bi-modal settings, by combining those two modalities, this DNN reached 97.1% and overall 98.45% accuracy was achieved. Okay, and what does this mean, for example? With 98.45% accuracy means users, there is a false accept rate of 0.2, which is very, very low. So, with this I reach my conclusion slide, for example. Here I have presented a user-friendly. Why I am saying user-friendly? Because it is not forcing you to remember anything. You can choose whatever you would like to write, 8-digit pin, whatever you would like to write. So it's a user-friendly mechanism with 98% accuracy means it's accurate. And this scheme leverages 2 hidden behaviors. These behaviors are hidden. Someone can see what you are typing, someone can see what you are writing, but how you are writing is extremely difficult. Both of these layers are invisible, to be honest. So DNN worked well achieving this much accuracy in bi-modal settings. And what is the way forward? I'm in the process of finalizing the proof of the concept implementation. Once this application is created, for example, we will check in cross-vendor settings on Apple, on iOS, for example, on Android. And I need to see performance analysis. I will how my application is going to impact, this in terms of computation, in terms of memory, in terms of testing time. Testing time is also important. And more testers and experiments in the wild settings. Security analysis also, like, it would be interesting to see how my approach is secure enough, for example. And usability in address is also important. So, with this, thank you so much. I reached at the end of my talk.
Thank you very much. Are there any questions from the audience? Question? Okay. Or questions just for some curiosity, actually. So you use this only for standard authentication, not for continuous authentication, because otherwise you should catch also for example, the touch stroke dynamics. So, is this a limit for your approach? Can you extend to continuous authentication in your approach or not? This is not clear for me.
Thank you for the great question. The point is, if I use these two modalities and use it to continuously authenticate users, it is not going to be a continuous authentication. It's going to be a periodic authentication. No? But for continuous authentication, there are many ways how I'm saying that. Because like the way you actually hold your phone, and from holding your phone or from unlocking your phone or from trying to using your phone, for example, by collecting data from different sensors which are already installed, you can continuously monitor whether or not the person who is actually the owner of this phone holds this phone or not. So I'm also working in that dimension too, but these two modalities, I think they cannot be used to authenticate continuously.
Okay. And the second question is about signature. So you in the registration phase, the user signs something, so send their signature, and then the system is able to recognize the signature. But why don't you use? You choose to use the signature and not a challenge text, a challenging text. So a text that is it is sent to the user as a challenge, so the user can because if this solution is prone to reply attacks, and in some sense the user has to send some sensible data. The signal can be used in different authorizations. So maybe for my idea is that it should be better to use some text, not preliminary fixed, and if probably your system is able to recognize that this text, that text is written by the user, non the legitimate user.
Okay, thank you very much. I will think for this idea when I will develop this application for a banking scenario, let's say. Because here, for example, the claim is to facilitate an ordinary user, okay, who is used to sign the way he wants, number one. Number two, for example, that's why I'm saying it's user-friendly. So because you are used to write your name in a way that no one is able to copy, number one. And here, we are not going to use images. So only the way you are writing on the screen, you are used to write your name, right? So on the screen, the way you are writing is sufficient enough to authenticate you without actually getting anything, so you have to follow that particular thing. But yes, in sensitive scenarios, banking for example, this could be added as an additional layer, for example. This could be done.
Okay, thank you very much.
You are welcome.
Yeah. Okay. Let's go to the third presentation. The paper is titled Achilles